Hi, welcome to another session of the 4AC work tutorial example. Here we want to look at past year exam paper, August 2014, question 2. The questions comes in two parts, part A and part B. In this video, we look at part A. A supply voltage ET is connected to the circuit shown in figure 2 below. We want to calculate the total impedance of the circuit in polar form. As we look at this part, and we want to calculate the current, the branch current that is flowing through, the total current IS, the branch current IR, IC, and IL in phasor form. And finally, we want to draw a phasor diagram showing the phases for the voltage and the various currents. Now, let's get started. Now, to answer this question, we first need to look at total impedance, right? So total impedance, since these are in parallel, we have to use the impedance in parallel formulas. That means 1 upon ZT is equals to 1 upon ZR plus 1 upon ZC plus 1 upon ZL. So that gives me 1 upon, I write in the polar form since we're going to divide. So this will be 60 at an angle of 0 degree ohm plus 1 upon 40 minus 90 degrees. Remember, capacitor is the negative phase shift, 90 degrees, plus 1 upon 20 the angle of 90 degrees. That gives me 0.0167. I straight away convert to rectangle because I need to add them. So minus 90 become positive, right? So I can write here positive J 1 divided by 40. Now 1 divided by 40 will be 0.025, right? 0.025. Here is 90 degrees. Anything mine divide means you become negative, right? So here become negative J 0.05. That gives me 0.0167 minus J 0.025. Okay, so this is in the rectangular format. So I change it back to polar. Right? Polar will becomes 0.03 at an angle of minus 56.26 degrees. Minus 56.26 degrees. Now this is not ohm, this is the inverse of ohm, so call this Siemens. Which means that ZT is the inverse of this value. 0.03 at an angle of minus 56.26 degrees. That gives us the total impedance as 333.33 at an angle of 56.26 degrees ohms. Okay. So that's in polar form. I can also convert this back to rectangular form. That becomes 18.512 plus J 27.716 ohm in the rectangular format. Alright, so that's for part A, subsection I. Alright, we next go on to A subsection 2. A subsection 2 wants us to calculate the total current IT of this circuit. So we can use Ohm's law's formula, E over ZT. That's 325 divided by root 2 at an angle of minus 30 degrees. So divide by the impedance we have calculated earlier, angle of 56.26 degrees. That will give us a total current of 6.893 at an angle of minus 30 minus 56. That will become minus 86.26 degree ampere. Right, and to calculate the other branch circuit current, we can write here IR. IR is E divided by the impedance of that branch, which is ZR. So we'll get same thing, 325 divided by root 2 at an angle of minus 30 degrees, divide by 60 ohms at an angle of 0. So that gives me a total current of 3.83 ampere divided at an angle of 30 degrees negative, so ampere. Okay. IL is E upon ZL, which is 325 divided by root 2 angle minus 30 degrees, divide by the impedance of L, this case is 20 at an angle of 90 degrees. So that will give me about 111.5 at an angle of minus 120 degrees. Finally, the branch current going through the capacitor is actually, let's see, 325 divided by root 2 at an angle of minus 30 degrees. The whole thing divided by 40 ohms minus 90 degrees. That gives me 5.75 ampere with a phase angle of 60 degrees. Ampere. Right, so we have all the 4 currents with different angles and so on. And finally, for part 3, we are required to draw the phasor diagram. Now we can start with horizontal line. E is at minus 30 degrees. Okay, that's E. IS is at minus, so that's not sure IS is minus, where this angle is 86.26 degrees. IR is at minus 30, so it's the same as the, so this is IR. IL is at minus 120, so let's put it down. So IL, this angle is 120 degrees. IC is at positive 60. Starting at 60 degrees. Alright, so that's the phasor diagram. Phasor diagram for part A of this question.